Hey guys, this is a tutorial on how to use Excel to build a bar graph that will have error bars. Recall that during the first week we went ahead and did the metric system, and in there we collected some data and then analyzed it, or at least calculated means and standard deviations. And you did it in the context of studying a frog population, and this is our local one of our local frogs called the Rio Grande leopard frog. And what you were supposed to do, and everyone was supposed to do, was to look at group A tadpoles and look at group B tadpoles. There was something different about the two groups, but you were supposed to use an Excel spreadsheet that had a random generator, a number generator that allowed you to pick 7 of these tadpoles at random. And every other student was supposed to do that. So nobody's going to end up with the exact same 7 tadpoles. So everybody should have different data set for group A and for group B. And then in that lab, there was a tutorial lesson on how to calculate the average, the mean, and the standard deviation for both group A and for group B. Now, you did that and you submitted that practice for what was equal to you submitted that for a grade. Now the thing is, once you calculate the average and the standard deviation, and you think about what we did, you quickly realize that no two students are going to get the exact same mean and standard deviations for each group. So this is an example. This is the mean and the standard deviation, X bar and S, for group A and then group B. Now, remember that in week 2 last week, we went ahead and I provided you a scenario with what was done. You were given a scenario that said that these were actual tadpoles that were grown in a lab after you went out to a wildlife area with a permit and you collected 60 eggs from this frog, and then you went and you randomly separated them into 2 groups, and in group A you fed them lettuce and in group B you fed them a meat diet, and then you waited approximately 4 weeks or so before you measured them, and then you were able to from the data you collected during week 1, that was what was basically the scenario. It became the scenario that after 4 weeks you went in and you measured your randomness, and you're able to move this ruler around and line it up to measure those tadpoles. So what you're looking at here is my data set, and everybody should have different mean and standard deviations. What we're seeing here is if there's really a pattern or effect in what we did in the experiment back in the lab, giving 1 lettuce and 1 meat, then we should be able to see that data should reveal that difference. Now, the means are always going to be different. We could run this experiment and feed a group of tadpoles lettuce over X amount of days and then measure how big they are, and you're going to get a different mean. You can do it 100 times, you're going to get different mean and standard deviation. The same thing for the meat diet. But the question is, that's just due to the random variation that we get. Now, the question is going to be, is what we did really significant or not? Now, the book, your lab manual, actually talks about that. We had a tutorial on this last week on how we're going to test our hypothesis. And what we're doing is we're testing for what is called a significant difference. And the big idea here is to know that, and I wrote a few notes here on the side, this is on page 5 of your lab manual, is that we're never going to really know the true mean. And the means are always going to be different every time we do it. So if for 2 groups, you're always going to get different means, but that doesn't mean they're significantly different. And what we're really trying to do is we're trying to assess, which is my 3rd bullet right here, is we're trying to assess if there's a difference between the means, if that difference is just due to random variation, random chance, or if it is caused by the test factor that we're doing. And in order to do that, we have to use the measure of variation, that standard deviation we calculated. So there's more formal tests to do this involving probability, but like your lab manual says, this is beyond the scope for this first year biology course. You'll probably be having to take stats for most majors. It's a good idea to take stats, especially if you're going to be studying biology, chemistry, geology, any of the natural sciences, which includes mathematics as well. So in instead of doing those more formal tests involving probability, the book provides us with an objective way to assess that variation to see if the factor was causing any differences we saw. And so that's here in the last paragraph here, and it's here in the italics. It says we're going to take the mean plus or minus 1/2 the standard deviation, and we're going to do that for each mean. The mean and the standard deviation, you're going to take the mean and you're going to add, and then you're going to subtract half of the value of the standard deviation. And then you're basically going to get a high value and a low value for each mean and then compare the ranges. Okay. So in other words, we're going to do this. So we had group A that was fed lettuce. You're going to take the mean for group A and you're going to add 1/2 of the value of the standard deviation to give us the high value. And then instead of adding, you're going to subtract. So when we say plus or minus, we're doing both. Okay. And so you're going to subtract that from the mean. And the standard deviation is the standard deviation for group A. You're going to be doing the same thing for the group B. You're going to add 1/2 the standard deviation for group B, and then you're going to subtract it. So by this point here, you've already calculated the mean and standard deviation for your data sets for the Tadpole data, and I have mine here. This is the ones I've come up with here. So here's my mean for group A. It is 27.6, and the units were millimeters, and the standard deviation was 1.3 millimeters. And then the group B for the mean was 32.0, and the standard deviation was 3.0. Now remember, we're supposed to take the mean, according to this formula, and add 1/2 the standard deviation, and then subtract 1/2 the standard deviation. So we actually still need to calculate the half standard deviation. We can do that real quick here with Excel. I'm going to take 1/2 is the same as 0.5, so I'm going to put in here, let me go ahead and put what this is. This is 1/2 S for standard deviation. And so what I'm going to do is I'm going to take 0.5, which is the same as half, and I'm going to multiply it by the standard deviation, and that gives me 0.6 rounded to one place past the decimal, and then I'm just going to copy the formula there. So this values right here are going to be what we add and subtract from the mean. So we're going to take 27.6 and add 0.6 and then subtract it to get our high and low range. Now you can do that on paper here within this table, but we can actually create a graph with error bars that allow us to do that right away. So here is how the nitty-gritty of this whole tutorial here is. We're going to create a bar graph. So in order to create a bar graph, we want to do it for the means first. So just go to Insert, and they'll have some graphs here. Select the bar graph and just select the basic bar graph. Now notice nothing appeared. So if we want to do a quick bar graph, we're going to highlight our means. So I'm going to highlight, I have the group A mean and the B mean side by side. And this is a quicker way. We could have done it the way I started, but now we have to go and tell the Excel where we want the data to come from. So this is easier to get it done this way. And there you already have the bars graphed for you. Okay, so now if you're going to put this in your lab report, you can always copy it. You can Control-C, copier, or left click and go up here and copy, and then go paste it on your document. Don't have a chart title on there. Whenever you put these in reports, you don't put a chart title, so you can remove that. You can also come over here to where it says chart design, and you can pick a quick layout. I usually sometimes like to go to where it already has the grid lines and the titles to put in there. You don't necessarily need a legend on this one, since we don't have the kind of data to support that. Now, we can see here that here on the side here, we need to put what the axis is going to be. Now, these bars right now are the averages, right? Group 1, which was the lettuce, is 27.6, and then 32.0 for the meat diet. And so for the axis title here, that's length. And you always want to put the units that are, and that appears there. And then this is the x-axis is the treatment. And in order to change those from 1 and 2, we can come over here to where it says select data. And we want to go to the right side over here, and we're going to put edit. And there it gives us for axis label range. And then we can just click on that arrow, and that's going to allow me to go and select what I want in the axis labels. You can put a group A or B, or even better, lettuce and meat to remind us there, and they appear right there. And now what we need are the error bars. So for the error bars, you come over here, and there's a bunch of options there, but where it says error bars here, you're going to click on there. And we're not going to do standard error, percentage, or standard deviation. We want to go to where it says more options here. And from there, you're going to go down to the bottom where it says custom. And custom, you're going to specify. Okay. And you'll notice that there is 2 fields to fill in. One is for positive error values, and the other one is for negative. And we're going to put the same thing in each. What we're going to do is we're going to tell it to graph an error bar that is plus 1/2 the standard deviation above the mean, and for the negative, minus 1/2 the standard deviation below the mean. So all we got to do is go click here, and that's going to allow us to come and select and make sure that you pick not the standard deviation, but the 1/2 standard deviation calculation. So go and highlight that, and you can see it put in the formula where those values are. And then you're going to do the same thing for the negative error bars. Remember, not the standard deviation, but 1/2 the standard deviation. And then you're going to be there, and then you click OK. And it has created error bars for you. You may want to do some other adjustments, it's kind of hard to see the error bars with this color scheme here. So you might go and format your data series, and you're going to want to make sure the border right now is white. So you're going to change that to black, so it creates a black line around there. And then you can go where it says fill, and you can change that to white. And so now you can see much clearer the error bars. Now, going back to the idea of the significance test. So those significance test is based on the error bar ranges, the high and low value. These are not the high and low values from your data set. This is the high and low value of 1/2 standard deviation. And what the test says is that if the low part of this higher mean does not overlap with the high part here, in other words, that ranges don't overlap, then the means are going to be judged to be significantly different, and that means there was an effect of diet on there. And they are different. It's kind of hard to see here, but this bottom of the bar there is just over the 30 marker, and the top of that error bar right there is below it, so the two don't overlap. So there's a significant difference here. Now let's say I've already talked to some students, and just because of their samples, they ended up where the error bars are overlapping, and that means there was no significant difference. So their null hypothesis cannot be rejected. So remember, the null hypothesis is not going to be a difference, and then the alternate is there is an effect, right? So I expect that everybody's lab report is going to go show some of those differences. Now, here's something that's interesting. There's going to be cases like this where you get you don't get a significant difference. But what will be interesting is to look at the pattern of repeats of this experiment, which is what every student is. And it's in there that we start to see a pattern. What you're trying to do here as the scientist who was doing this, it's a simulation, but you were doing this, is trying to see, is there enough evidence from your sample to suggest that there was an effect? But you never say proof, because you might get a different answer the next time you run it. We don't know. Remember, we don't know what the true means are, right? So you are trying to make an inference based on the information you've collected. You've tried to reduce as much bias in your samples and everything, and you're trying to make a judgment on whether or not this is supported. This is why we test and retest ideas, because science is never proven. It's just the best way we have of trying to uncover a series of better truths. So I hope this tutorial was helpful. And if you can, use this to create graphs for your future reports.